Hello YouTube viewers, welcome to my show Science Thursday. In episode number 5, we're going to take a look at something. So I want to ask you this question. What does an electric engine, a diesel engine, an electric car, a microinductor, AC has in common? If you have read the title of this video, you know the answer. So let's get into inverters. So what are they? Well, they are very simple thing. They just convert DC into AC. So this is a DC where voltage is just going as a line, and this is AC where it's going on and off, on and off. We have it at 50 hertz. Some places have it 60 hertz. So that is the frequency of your AC, on and off, on and off. So what does that mean? It's going on and off 60 to 50 times in a second. So how do we feed inverters? We can feed inverters either by rectified means. Basically, we take this, make that into this, which we do with bridge rectifiers. Quite simple device, nothing fancy about it. Or we have batteries like your UPS, home inverters, or electric cars, or fuel cells also. Even though, so if you see a hydrogen power car, it also uses inverters because fuel cell also creates DC current. AC is much more useful. So let's dive into it. So how does it do it? One very simple thing you have to understand, it's basically made out of two components. One is the switch, second is the fact that it can switch it based on a cycle or pulse width modulation signaling. So you must have seen this and this diagram all around the net showing this is the inverter. It's true and it's false also, because all you are seeing is the switch unit, but you are not seeing how the heck these switches are turned on and off. That's what you have this for, pulse width modulation. So if you built this electrically speaking, you're not going to get anything. So for this to actually have getting this output, you need a switching mechanism. This is how we ended up creating a sine wave inverter. What we did is all these switches, we are turning them on and off much more than it is needed. In older designs, which you can call it square wave, what we used to do is only do on and off 60 times a second, as to make 60 hertz means power. This, however, because of advance of fast silicon electronics or solid state IGBTs, we can do that thousands of times a second. So what does that allow us? Using this signal, pulse width modulation signal, basically we are making like, first pulse like okay, little bit, second pulse bit bigger, third pulse bit bigger. We are creating a step-by-step situation where it's going up. The voltage is going up. If you do on and off, all you will get on, off, on, off. You won't get the wave pattern. So sine wave inverter is very necessary. So that's why we use pulse width modulation, where we are saying okay, on for this many second, okay, off, on for this many second, off, on for this many second, off. So this is the pulse width modulator. This is what's driving this. So if you see this or this H bridge rectifier system, this itself is not an inverter. You need to control these circuits through something. So these are the two main components of an inverter. Everything else is just secondary to do maintenance, basically controlling temperature, overload protection and all that. So all your inverter, the engines, everything is just this switches controlled by a computer that's telling it how quickly on and off it should do. So now we know where inverter is, now we know how it's so what does it allow? We made an inverter, okay, cool, everything is fine, we get DC to AC. So what does it allowing us? Well, it's allowing us what's called independent control. So there are two main factors to AC electricity. First is the amount of voltage it has, the height of the system. System as in like the wave, how high is going. Like in our case, we have 220 volts. So that's the voltage, and you might say amperage, but amperage is specific to the system, so that's why we are not counting that. And then it has frequency, how often is going on and off. Now on and off has a very unique advantage where, like induction motors, which are used in almost everything, 90% of industrial world runs on it, including your normal water pump to saw blades, and almost everything is running on induction motor if it's powered by something that is powerful, like either a generator or AC mains. So frequency allows its RPM to be controlled. Now here's the trick. Because it's allowing independence control, you can change those two things independently, the frequency and the voltage. You might be like, okay, what's the point of it? Now here's the thing. Anybody who's dealt with cars, locomotive or anything, they must have known there are two simple factors, the speed and the torque. Now these two are independent in an electrical motor. Torque is directly proportional to the voltage and the speed is directly proportional to the frequency. This is the magic bullet of inverters. This is why your AC nowadays have an inverter system. What it's allowing, it's like let's say you turned your AC on, it's quite hot. It knows it needs to cool the air down, so it can overdrive the motor. So it will increase the frequency from 60 Hz, let's say it's designed for, it will make it run at 70, so it's getting more work done and it's gonna calm it down. So let's say now your room is cooled, now the motor needs to run very slowly just to maintain it, so they're gonna be like, okay, let's decrease the frequency, so it will go to 30, 40 or even 20 Hertz, so it's only going 20 RPM, let's just say that. And let's say for some scenario, let's say outside temperature is very hot, you need to compress, like basically your compressor is requiring a lot of torque, you can increase the voltage. Now this is the reason why electric cars use inverters, because they can control two different things independently. As you can see in this graph, this blue line represents torque. Now this is the unique about electric motors, is they have 100% torque the moment you turn them on, and power, the RPM basically goes up as the frequency goes up. So controlling this allows us to make very precise movements, and basically anything that rotates sooner or later has an inverter to it. Now it's not necessary, but it allows us control. That's why diesel locomotive really relies on it. Without it, it simply wouldn't work. Like you can have DC motors, but DC motor does not have direct control of their speed. So if you giving more voltage, they will start overspinning, wheel slippage will occur. So all things considered, you have to understand, because of these two factors, that they can control these two things independently of one another, they are everywhere. Like I'm not even joking, like your CFL actually has a small scale, obviously small scale version of frequency driver where it's increasing the frequency, and many things, almost everything has one way or another of form of inverters. So you have to understand, inverter changed the entire world, and it's no understatement. Like if we hadn't developed the inverter technology that we have today, we would be quite back. We'll be quite behind schedule, so to say, on our road to future. So that was my presentation. Hope you guys liked it or learned from it. In that case, please like. If you didn't, dislike. Leave a comment, and if you are free, like and subscribe, because I make content every day. So thanks for watching.